So any questions about augmented matrices? If I give you a system, can you write the augmented matrix? Okay. The next objective that we have to talk about is performing matrix row operations. When we solved matrices in Algebra 2, we did not solve them using matrix row operations. Okay? We solved them using substitution, or we solved them using elimination. We solved them, if they were linear, by graphing. We solved them using reduced row echelon form in our calculator. We didn't ever do matrix row operations. So I need to make sure that you understand how to do a matrix row operation. Okay? So I'm going to start you off with this matrix right here. 3, 18, negative 12, and 21. 1, 2, negative 3, and 5. Negative 2, negative 3, 4, and negative 6. Okay? So I want to be clear to you that this is row 1, this is row 2, and this is row 3. Is everybody clear on that? Okay. So the first thing that they'll ask you to do is something like this. It'll say, what do you think they want you to do? Swap them. So the answer to that problem would be 1, 2, negative 3, 5, 3, 18, negative 12, 21, negative 2, negative 3, 4, and negative 6. That's pretty ridiculously easy, isn't it? All right? Because here's the deal, guys. In Gaussian elimination, which is the thing that we need to talk about next, I'm going to go ahead and talk about it a little bit right now. In Gaussian elimination, you want this diagonal to be what? Do you remember? You want it to be 1s, right? Now, we went all the way to Gaussian Jordan elimination when we do reduced row echelon form in the calculator, and everything else is 0s, right? In Gaussian elimination, this row is 1s, and these 3 right here are 0s. And that's it. Okay? But do you see why we switched row 1 and row 2? Well, then this is already a 1. We didn't have to do any math. We just had to do some row swapping. You okay with that? Okay. So what if they ask you to do this? On the original matrix right up here, not on this new one, but on the original one. What do they want you to do? Multiply everything in row 1 by 1/3, right? So 1, 6, negative 4, and 7. What should we do with row 2 and row 3? Yeah, leave them alone, right? 1, 2, negative 3, 5, negative 2, negative 3, 4, and negative 6. You okay with that? Okay. Last but not least, let's do this one. Oh, I wanted to use a different color. Where's my other color? Two row sub 2 plus row sub 3. So we need to add 2 times the elements in row 2 to the corresponding elements in row 3. And we're going to replace row 3. Okay? So that means what's happening with rows 1 and 2? They stay the same, right? 3, 18, negative 12, and 21. 1, 2, negative 3, and 5. So 2 times row 2 and then added to row 3. Well, what's 2 times row 2? Plus row 3. So 0. Okay? What is 2 times row 2? 4 plus row 3. 1. What's 2 times row 2? Negative 6 plus row 3. So negative 2. 2 times row 2 plus row 3. 4. Okay, so do you understand about row operations? Okay. Using row operations is how we solve matrices, solve systems of equations with Gaussian elimination. Okay? Let me look something up really fast. I thought it was here, but oh, there it is. Gaussian elimination is actually named after a German mathematician named Carl Friedrich Gauss. He lived from 1777 to 1855. He's pretty famous for a lot of things in mathematics, mostly because he did a lot of things in mathematics. I don't think he murdered anyone. Oh, he was a nerd. Yes, for sure he was a nerd. Okay? He was a giant nerd. Here's how we use Gaussian elimination. Okay? 3x plus y plus 2z equals 31. X plus y plus 2z equals 19. X plus 3y plus 2z equals 25. Now, I would be tempted to start doing multiplication right now, especially by negative, to eliminate row z, or the 0 column, excuse me. Okay, that's not Gaussian elimination. So here's what we're going to do. First of all, we're going to write it as a matrix. Okay, 3, 1, 2, 31. 1, 1, 2, 19. 1, 3, 2, 25. Okay, so that's our augmented matrix, right? Okay, so we're going to use matrix row operations to simplify the matrix into row echelon form. That means this row of diagonals right here is 1. And everything below that, so these 3 right here, 1, 2, and 3, are all zeros. Do you see that's a little bit different than what we did in Algebra 2 with the reduced row echelon form? This is just called row echelon form. It's not the reduced one. Okay? So our first goal is to get a 1 in this top column. Okay? Well, the easiest way to do that is either to switch row 1 or row 3 with row 2 or with row 3 with row 1. Does that make sense? So let's just switch row 2 and row 3. Okay? So we say row 1 switched with row 2. Okay? So the new matrix would be 1, 1, 2, 19, and 3, 1, 2, 31. And then, of course, row 3 stays the same because I didn't do anything to it. Okay? Now, that's nice because I have a 1 here and a 1 here, not a 1 here, but except these aren't zeros yet. So that's what I need to approach next. Okay? So the way that we get zeros where there's a 3, like right here, is let's multiply the top row by -3 and add it to the middle row. Does that make sense? So -3 times row 1 plus row 2. Whoops. Row 2. That's what I want to do. It's not going to equal row 3. It's going to get row 2 to eliminate. Okay, so if I multiply the top one by -3, I would get -3, -3, -6, and what's 19 times -3? Thank you. Okay, so now I'm going to combine that top row with the middle row. And I guess I should have written this thing right here, because that's the row I'm replacing. Does that make sense? Okay, so the top row stays the same, and the bottom row stays the same. To get the middle row, I've multiplied the top row by -3. That's these little baby numbers up here, and I'm going to add it to the middle row. So it's -3 and 3. 0. That's what I needed, right? But now I have -3 and 1. That's -2, -6 and 2, negative 4, and then negative 57 and 31, negative 26. Okay? Now, do you remember what I said this diagonal right here needs to be? All ones, right? And then these three numbers have to be zeros. Okay? So, do you see any way to make that a 1? We could multiply row 2 by negative 1/2. Wouldn't that work? Okay, so if I do that, 1, 1, 2, 19, 0, 1, 2, 13. 1, 3, 2, 25. I keep forgetting my line, sorry. Okay, so far? Now, what does, let's see, I'm trying to figure out what we want to do next. I need this to be a 0. So can I subtract row 1 from row 3? Can I do row 3 minus row 1 and write it in that row? Okay. So 1 minus 1 is 0. 3 minus 1 is 2. 2 minus 2 is 0. 25 minus 19 is 6. Okay. What do we want right here? A 0. Okay. So how do you think we can make that be a 0? If we multiply the second row, now I don't want to mess with anything in the first row, right? Because if I multiply anything with the first row and add it to the last row, I'm going to get a 1 right there. I don't want that for sure. So if I mess with these middle two right here, if I multiply the middle row by negative 1/2, wouldn't that work? And then add it to row 3. Excuse me, negative 2. Thank you. Okay, so if I multiply row 2 by 2 and subtract row 3, is that what I want to say? I think it is. So row 2 times 2, that's 0, a 2. I think what I was trying to say is negative 2, because that's a 4, and that is 26. That's kind of what it was a second ago, but I'm not worried about that. So I could have multiplied it by negative 2 and then added, right? But now I'm subtracting. So I almost have room to finish it on this page, or finish this step. 0, 1, 2, 19. 0, 1, 2, and 13. So if I add these two together now, I get 0. Subtracting. 0 minus 0. 2 minus 2 is 0. 4 minus 0 is 4. 26 minus 6 is 20. Thank you. Appreciate it. Okay, so we're almost done now because this needs to be 1s and these 3 have to be 0s. Well, these 3 are 0s, but I've got 1, 1, and 4. But what do you notice right here? Yeah, we're going to take row 3 and multiply it by a 4th, basically. Okay, when we do that, we get 1, 1, 2, 19, 0, 1, 2, 13, 0, 0, 1, 5. Okay, so now my diagonal is 1s, and then these 3 are 0s, right? So this takes us to a system. X plus y plus 2z equals 19. Y plus 2z equals 13. And z equals 5. Does everybody see how I got back to that system? Okay. Now, That is in the correct form for Gaussian elimination. In order to solve this system, you have to do something called back substitution. We know what z is. Take it here, plug it back in, substitute it back in to solve for y. We know z and y, plug it back in and to solve for x. That's back substitution. Okay? That's Gaussian elimination. Does that make sense? So, the difference between Gaussian elimination and Gauss-Jordan elimination is what we're used to. Okay? What we're used to is ending up with a system that looks like this. Where the diagonal that we have is 1s, and these are 0s, just like in Gauss elimination, but also these are 0s. Okay, that's what's different. So it's basically, excuse me, using the same kind of row elimination that we talked about in Gauss elimination, but also using it to eliminate these three up here. Okay, do you need me to do a whole example like that, or you understand what I'm talking about? You got it? Okay, if you have any questions, you know you can come and ask. Okay, so if I give you a system, can you write the augmented matrix? Can you perform given or asked for row operations? Okay, and are you okay with Gaussian elimination and Gaussian Jordan elimination? Okay.